Okay, so who remembers what we were talking about last time? Well, yes, the very, very last thing we were doing though when we were together was we were finding the area. And I had given you a wonderful, wonderful new formula. Anybody remember what it is? Area of the triangle now.
1/2 side side.
1/2 side, sine of included angle, right? So 1/2 side, sine is how I remember it, but the angle must be included between the two sides. So let's take a look at this scenario. Last time, I don't know if you remember that, but last time we had a triangle where we knew this was like 13, and we just did 1/2 side, sine, and it was so simple. In order to do that, I need another side of this triangle. Would you all agree with that? Yeah. So I want you to stop and look at the situation and tell me if we can find another side.
Yes.
How? Law of sines. So we can find side A real handily. Sine 57 over 12 equals sine 43 over A. Agreed? So now we can find side A. Which is 12 sine 43 divided by sine 57. Did you get 9.76?
Yes.
Now, I have two sides. So I can find the area by doing 1/2 side times side. Now be careful, times sine of what? What angle do I need? If I'm using these two sides, I need angle C, which is
80 degrees.
80 degrees, yep, you're right. Now, one more little hint here. Oh, never mind, let's just type it in and see what we get. So 0.5, 12, 9.76, sine 80. Did you get 57.67?
Yeah.
And I didn't put any units on here. Oh yeah, I did centimeters. So the area of this is going to be square centimeters. So 1/2 side sine is a hugely valuable tool. But you got to have two sides in the included angle. If you don't have that, then you'll have to find it. Okay? Next. Okay, I have two sides, but I do not have an angle.
It's all right.
It's all right, we can find it. How can we find an angle? Not going to be the law of sines, that's for sure. So I guess it's going to have to be the law of cosines. So pick an angle that you want to find. Do you want to find A, B, or C? A. All right? If we want angle A, then the law of cosine says, out here we're going to have cosine A. And over here we're going to have 16 squared. Is that coming back to you?
Yep.
So then in the middle here, law of cosine says, you're going to have 12 squared plus 10 squared minus 2 times 10 times 12. That's the law of cosines. That's how it works. So let's say somebody's a road out there and you decide you want angle C. Well, then yours would have cosine C, and then over here would be 10 squared. Yes. And then in the middle would be 12 squared plus 16 squared minus 2 times 12 times 16. So you can find whatever angle you want. We're doing A. Now, we actually did one of these the other day, and I cautioned you about just being careful about typing this in. You cannot just combine all of that because of that cosine there. So let's see how far you can get with, solving this. We're trying to find angle A. Tell me, how did I do? Do I have arithmetic mistakes? That's what you got? Anybody have a question about what's happening here? This is 256, 144, and 100. You can add these and subtract them from 16, swear. I did that, I got 12. You can multiply all those together, but you can't combine this stuff and that stuff. Okay? All right. Now, can I find the area of the triangle? That was my goal. So now, what will the area look like? Area is going to equal 1/2 times 12 times 10 times sine this angle. Now, I need everybody to do one thing for me. I hope you haven't already started typing in. The last thing on your calculator, you second cosine and got 92.87. So the whole angle is there, all right? So what I want you to do is do 1/2 times 12 times 10 times sine answer. And on the old calculators like mine, you have to do second answer. Second answer. On the newer ones, you can actually cut and paste or whatever. But I want you to get as close as you can. I got 52.924907, and I'm writing all that out for a reason. I have a purpose for this. Did you all get that? Okay. Oh, no, it's 59.9249, okay. All right, now, you're all sitting down, and that's a good thing, because you are about to have your socks knocked off.
Oh, no.
Oh, yes.
Oh,
Oh, yes. So here's what I need you to do now. We are now going to type in, I gotta make sure my arithmetic's right here. We are gonna type in 19 times 9 times 7 times 3, and we're gonna square root that number. So just do that for me. I'm gonna square root 19 times 9 times 7 times 3. What? Is that not the coolest thing in the world?
Where'd we get those numbers?
Where'd we get those numbers? That's what we're gonna talk about. So, this little formula right here is called Hero's formula. The guy's name was actually Heron of Alexandria. We're talking about a formula that's centuries old. Here's what this really smart guy figured out. If you know all three sides of your triangle, and we never use hero unless we have all three sides, okay? If you are given all three sides of your triangle, step 1, find the perimeter of the triangle. Okay, what's the perimeter of this triangle? 38. The formula says, take half the perimeter. It is called the semi-perimeter. Half the perimeter. So, I'm gonna write it over here. So half the perimeter would be what? 19. So we're gonna take our semi-perimeter. Then we're gonna take that number, that semi-perimeter, and we are gonna subtract each side of the triangle. So 19 minus 10 is 9. 19 minus 12 is 7, and 19 minus 16 is 3.
Interesting.
Well, I think that formula is cool. It's so easy to use, but imagine being smart enough to figure that out.
Are we allowed to use it?
Oh yeah, we use it all the time. Anytime you have all three sides, use Hero's formula. You don't have to go through all this stuff, right? I mean, if you'd rather go through all this stuff, you can. But Hero's formula works so beautifully with all three sides. All right, so we got another one. Here we go. Look at problem D. What have we been given in the problem? All the sides. So we can definitely use Hero's formula. I'm just gonna pause for a second because I graded a lot of papers over these many years. The biggest mistake that is made, actually there are two big mistakes that are made. One is kids use 38. It must be the semi-perimeter. You have to use the semi-perimeter. The second thing is, these other numbers that I'm multiplying by are not the sides. They are the semi-perimeter minus the sides, okay? Make sure you're doing it right if you're gonna use that formula. Okay, what's our perimeter for this one? And I'm gonna divide that by 2 because I need the semi-perimeter, so I'm gonna have 24.35. And then I'm gonna have that minus each side. I'm using my calculator, so I don't care about the decimals, it's all gonna be fine. Well, maybe it's not all gonna be fine. What happened? Tell me about this situation, guys. What the heck is going on?
There's 0 triangles possible.
That triangle's not possible. That triangle's not possible. I want you to think back to geometry. I want you to think back to geometry. What do you know about two sides of a triangle? They must always add up to be more than the third side. I want you to think about that for a second. Think about a triangle. It's 8.2, 10.5, or whatever it was, and 28. Even if you laid these two sides straight down, they wouldn't make 28, right? The rule says two sides of a triangle must add up to be more than the third. That didn't happen, and Hero discovered it for us because our answer came out to be imaginary, right? No triangle possible. All right, one more, and then we're gonna go to lunch. We're gonna
Go.
have a really fun problem.
I love these fun problems.
I know.
Miss Ford, you're making that fun.
I don't have to make that fun. It is fun.
It's only fun with you though.
Okay. Find the area of a regular hexagon inscribed in a circle. Oh, all right. So here's how I'm gonna draw this. Remember, nobody's gonna grade your picture, but it might help you with the problem if you have a reasonable picture. So, I have a circle. Inside that circle, inscribed, inside that circle is a hexagon. Hexagon means 6 sides. So I drew 6 relatively evenly spaced hash marks around my circle. Now, I'm gonna connect those hash marks, and there is gonna be my hexagon inscribed in a circle.
That's crazy.
Easy, okay? Now, your job is to find the area of that hexagon. Now, I am told that the circle has a radius of 12 inches. So from the center to each of my hash marks, is going to be 12. If I draw in all of those radii, you notice that I now have triangles. There are 6 of them, and they are all the same. So if I could somehow find the area of this triangle, let's say, then I would times it by 6 and have my answer. Would you agree?
Yeah.
Okay. Now, if I'm gonna do area, I need more information than I have. Meg?
So, like, the point in the middle is it goes around 360, so you divide 360 by 7.
Bingo.
And then you got a 60.
Meg says, look guys, look, all of these angles, there's 6 of them right here, and they are all gonna add up to 360. They're all equal to each other, so therefore they must be 360 divided by 6.
So it's 6.
So that's a 60.
Wait, but then all of them.
I don't even care about all of them, because what do I have now? 2 sides and the angle in between. So what is the area of that triangle? 1/2, 12, 12, sine 60? And then the hexagon will be 6 times that?
Yeah.
That's so big.
So here we go. 1/2, 12, 12, sine 60. And then don't even write it down, just hit times 6. Did you get 374.12 square inches? Now, wait, I want you to think about this for a second. What if this had been a pentagon?
5 sides.
So that would be, I would do everything the same, but I'd only have 5 triangles in there, and there would only be 5 angles around here.
Yeah. So 365.
360 divided by 5. Wouldn't I do it exactly the same way?
Yeah.
Decagon, octagon, who cares what gon? This is the strategy you're gonna use, right? Okay. All right, I'm back at 50. Back at 50. You're welcome, make lunch fun. Somehow manage without me.